All right, so this lesson is on what are called direct variations. So a big part of algebra is spent working with what are called linear equations. And these are equations that when you graph them, they graph as straight lines. And there are different forms of linear equations. Well, most algebra courses will start with direct variations because direct variations are the easiest form of a linear equation. So an equation that's in the form of a direct variation is simply y equals some number times x. So just as a quick example, here's an example of a direct variation. Y equals 3x. Y equals negative 2x. Excuse me. Y equals 1/2 x. So a direct variation is just y equals some number times x. Now this number here in front of the x, we call that k, and it's called the constant of variation. So k is called the constant of variation. And the only requirement is that k can't be 0. So it can be a fraction, it can be a decimal, it can be an integer, so that means it can be positive or negative. It just can't be 0. Because if it was 0, then you just have y equals 0. And that's not a direct variation. Okay, so I want to show you something real quick. So we've got y equals kx. It's a direct variation. And I want to solve this for k. All right, so to do that, I'm just simply going to divide both sides of this by x. And what I end up with is that k, the constant of variation, is equal to y over x. And this becomes important because if you know that you have data that is a direct variation and you want to write this equation, this shows you how you can find the constant of variation or the k value. You just take a y value divided by an x value and it will give you the k value. And I'll show you some examples of that. All right, so the first part is just identifying an equation that's written in the form of a direct variation. So the question is, does the equation represent a direct variation? And if so, what is the constant of variation? All right, so what you want to do is solve these for y. So you want to get the y by itself to get it in the form of a direct variation. So for this one, what I want to do is divide both sides of this by 7. Those will cancel out. What I end up with is y equals 2/7 times x. So this is a direct variation, yes, and the constant of variation is 2/7. Okay? All right, so let's look at this next one. So I'm going to subtract 4x from both sides. So now I have 3y equals 8 minus 4x. And then I'm going to divide by 3. And so what I end up with is, write it over here, y equals 8 minus 4x divided by 3. And the answer is no, this is not a direct variation. So in a direct variation, there is never any adding or subtracting. Apologize for my cough today. So there's not any adding or subtracting. It's always just y equals some number times x. So if you have adding or subtracting, it is not in the form of a direct variation. Now, I will tell you that this is a linear equation. If you graph this, it graphs as a straight line, but it is not a direct variation. So again, remember, direct variation is really the simplest form of a linear equation. All right, so one more here. I'm going to subtract 4x from both sides. So those cancel out. Now, 0 minus 4x is just equal to negative 4x. Just like 0 minus 4 would be negative 4. All right, divide both sides by 5. So what I end up with is y equals negative 4/5 times x. So the answer is yes, this is in the form of a direct variation, and the constant of variation is negative 4/5. All right, so let's move on. All right, so now we're going to look at how do we write a direct variation if we're given an x and a y value. So suppose y varies directly with x and y equals 35 when k equals 5. Excuse me. What direct variation equation relates x and y? And what is the value of y when k equals 9? So there's two questions here. So the first part is write the equation. So I'm going to go back to the first slide here real quick. And remember, I had you solve the direct variation equation for k. And what we discovered was that k, the constant of variation, is equal to a y value over an x value. So we're going to use that. So we're going to come back here and we're going to say k equals y over x. And in this case, y equals 35 when x equals 5. And that simplifies to 7. So our equation is simply y equals 7x. That's our direct variation. Easy. All right, now it says, what is the value of y when x equals 9? So we're just going to substitute this in. Write this down, substitute that into the equation. So we're going to take y equals 7 times 9. So again, we started with y equals 7, and I wrote 9. Y equals 7x, that was our equation. I substituted in 9 for x, and so y equals 63 when x equals 9. There you go. So there's your two answers. Okay, so let's look at another one. Suppose y varies directly with x and y equals 10 when k equals -2. What direct variation equation relates x and y? Okay, so again, k is equal to y over x. So k is equal to 10 over -2, which simplifies to -5. So our equation is y equals -5x. Easy. And then we're going to substitute in the -15. So they say, what's y when x is -15? Let's say y equals -5 times -15. And so y equals +75. All right, so pretty easy. Again, these are the simplest forms of linear equations. All right, so let's talk about what the graphs of direct variations look like, because the graphs of direct variations have some characteristics in common, and we want to know what those are. All right, so we've got this word problem here, and it says the weight on Mars, y, varies directly with the weight on Earth, x. The weight of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. So here's the weight on Mars. So keep in mind, this is a y value because they said that weight on Mars is y, and this is an x value because the weight on Earth is represented by x. All right. So to write this, they did this a little differently than what I showed you. So what I said was k equals y over x. So k equals 50 over 130. You can go ahead and divide that and change it into a decimal, and you would get 0.38. And so the equation is y equals 0.38x. All right, so that's the equation. And then it says, what is the graph of the equation? I apologize. So make a table of values, then draw the graph. So x is an independent variable. It's what you plug in. And y is the dependent variable. So your weight on Mars depends upon what your weight on Earth is. So for the independent variables, you can just pick values. So these x values in this table, they just picked them. They said, okay, let's use 0, 50, 100, and 150. And then let's plug those in. So that means multiply them by 0.38, and that'll give us our y values. Okay, now notice there are no negative x values here because x represents the weight on Earth, and you can't have a negative weight. So that's why you only see positive values here and 0. Okay, so once you have those values, again, the x values they just made up, they plug them into the equation to get the y values. Once you have that, then you have the x, y ordered pairs that you can graph. The x-axis is here, the y-axis is here. Again, your dependent variable is always on the vertical axis, and your independent variable is on the horizontal axis. So they graphed these points, 0, 0, 50, 19, 138, and 150, 57. And what you notice is that these graph is a straight line. Remember, I told you that direct variations are the simplest form of linear equations, meaning that they graph as straight lines. So the one important fact about direct variations is that they graph as straight lines. And the other important fact is that if you draw a line through the points, that line will always go through 0, 0. So that's something that's special. Sorry. That's something that's special to direct variations. So direct variations always pass through the origin 0, 0. Now, that point might not be on the graph. So let's say they didn't put 0 in the table. This point wouldn't be here, but if you drew a line through these points and continued it on, it would have hit 0, 0. So just, sorry, I thought there was a summary here. Now, last thing here, write a direct variation from a table. So for the data in the table, does y vary directly with x? So that's the first thing we need to find out. And if it does, then we can write the equation. So what we're looking for is we're looking to see if there's a constant of variation. So is y over x the same for all of these? And so what we're going to do is do y over x and see if they all come out to the same thing. If they do come out to the same thing, then we know that this data varies directly. So I'm going to do 6 divided by 4, and that gives me 1.5. And then I'm going to do 12 divided by 8, and that's 1.5. And 15 divided by 10 is also 1.5. So the answer to the question of does y vary directly with x is yes, because you can see y over x is constant. And so then the equation is simply y equals 1.5 times x. That's the relationship here. This y value is equal to 1.5 times the x value. All right, so we'll do the same thing over here. We'll do y over x. So 3.2 divided by 2 is 1.6. 2.4 divided by 1 is 2.4. And we can stop right there. We know that the answer is no. These do not vary directly because you don't have a constant of variation. All right, so I apologize again for the coughing. I've had this cough for like 5 weeks now, and I can't get rid of it. And yes, I've been to the doctor twice, and it's still hanging around. So I hope this was helpful and useful for you and made it easy for you to understand. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.